Welcome to TOC class. The second part of mathematical notation is inductive proof. So we are already aware that inductive proof can be solved by iterations of steps. In this category, there are four different types of inductive proof categories available. One is inductions based on integer. That means some formula, that may be a general formula, is available. Those general formulas can be solved by using first method. And then general form of integer induction, this is the second concept. Third one is structural induction, and fourth one is mutual induction. Let us discuss one by one later. The first method is induction based on integer. So you can solve this induction method in two steps. The first step is called base step, and the next step is called inductive step. Base step means you should give initial value. That means the hypothesis initial value will be given and we can prove whether it is true or false. So this is the initial step. And inductive step means if S of n means statement, that is nth value statement. If nth value statement is true, the same concept will be applied for n plus 1th statement. So we should prove this concept. So now we'll go to the problems. The first problem, prove that sum of I is equal to 1 to n I squared. That means the sum of squares of positive numbers. The formula is n into n plus 1 into 2n plus 1 by 6. We should prove this by induction method. So this is the condition. So the first step is we are taking case 1. Case 1 is a basis step. So what is the basis step here? The basis step is they are giving initial value I is equal to 1. So you consider LHS part of the given statement is sum of I is equal to 1 to n I squared. And RHS part of the given statement is n into n plus 1 into 2n plus 1 by 6. So substitute I is equal to 1 in both LHS and RHS. So sum of 1 squared. Sum of 1 squared means the initial value is 1. So the answer is 1. Here in RHS part, substitute I is equal to 1. I is equal to 1. Here the variable is n. So you can substitute I value to n. So the value is 1 into 1 plus 1 into 2 into 1 plus 1 by 1. That means 1 into 2 into 2 plus 1, 3 by 6. This is 6. So 6 by 6, it is 1. So the LHS part and RHS part are equal for the initial value I is equal to 1. Therefore, basis step is proved. Next, consider case 2. Case 2 is what? It is inductive step. What is inductive step? We should prove if S of n, then S of n plus 1. So consider LHS part. The S of nth statement is sum of I squared. The value is from I is equal to n. What is S of n plus 1? It is nothing but S of n value plus your n squared sum, which is nothing but sum of I is equal to 1 to n I squared value plus n squared. So you substitute the formula for sum of I squared from the given question. The answer is n into n plus 1 into 2n plus 1 by 6 plus n squared. So if you take the common value, that is for, we are substituting the same one for S of n plus 1. So this is n plus 1 squared. Okay, this is for S of n plus 1. So this is S of n statement. N plus 1th statement is n plus 1 whole squared. So if you take LCM of these two, the first one is n into n plus 1 into 2n plus 1 plus 6 of n plus 1 whole squared whole divided by 6. So if I am taking n plus 1 outside, the answer is n into 2n plus 1 at first part, and second part is 6 of n plus 1 by 6. So the answer is n plus 1 into n plus 2 into 2n plus 3 by 6. This is the answer for LHS part. I am taking RHS part, that is S of n RHS value is n into n plus 1 into 2n plus 1 by 6. We should prove the same value for S of n plus 1. So wherever n is available is substituted as n plus 1 in the given formula. So the answer is n plus 1, n plus 1 plus 1, that is n plus 2, 2 of n plus 1, that means 2n plus 2 plus 1 by 6. So the answer is n plus 1 into n plus 2 into 2n plus 3 by 6. See, if you take the previous one, the answer is of LHS part is n into n plus 1 into 2n plus 3 by 6. The RHS part is same thing. Therefore, LHS and RHS are equal. Hence, the problem I is equal to 1 to n I squared equal to n into n plus 1 into 2n plus 1 is solved by induction method. In this way, we can able to solve the second problem, that is sum of I is equal to 1 to n, n numbers. N number formula is n into n plus 1 by 2. You try to solve this same problem by using this following steps. Next, we will take the second method, that is general form of integer induction. In general form means instead of taking only one initial value, here we are taking several initial values. For I value, I plus 1, j value, like that. We should apply the same conditions for proving these notations. For inductive step, the general notation is if s of n, then s of n plus 1. But in general form of integer induction, we are taking an intermediate value as j, which should be greater than I, but it is less than n. So we should prove this concept in general form of integer induction. Let us take an example. If n is greater than or equal to 8, then n can be written as sum of 3's and 5's. This is a general form of integer induction method. Let us take an example. That is, the given statement is n greater than or equal to 8, and we can write as n is sum of 3's and 5's. So in the general form of induction, we are taking several basic steps. Consider the minimum value of n is 8. I am taking n is equal to 8, 9, 10, 11. I try to find a solution for this one. You should take multiples of 3's and 5's. So I am taking one number of 3 and one number of 5. So here it is a and b. I am taking one number of 3 and one number of 5. The answer is 8. 9 can be written as 3 into 3. 3 into 3. So, if you are taking 3 times A and 0 times B, this means this is A value, this is B value. You consider this one. N is equal to 10 means 2 times 5. So, there is no possibility of A, 2 times B. N is equal to 11 means 3 plus 3 plus 5. So, 2 times of A and 1 time of B. So, in general form, we can rewritten the same statement as n is equal to 3a plus 5b for all n greater than or equal to 8. So, it is proved for basis step. Consider an inductive step. What is an inductive step general method? If s of n, then s of n plus 1 for all n greater than or equal to 8. Let us take j value that should be less than or is equal to n. So I am taking less value. So n minus 2 is greater than or equal to 8. This is my assumption. So I am taking j is equal to 10. So 10 is greater than or equal to 8. We can able to write it as s of n is equal to 3a plus 5b. So if it is s of n minus 2, it can also be written as 3a plus 5b. Then we should prove s of n plus 1. That should also satisfy 3a plus 5b. So how can we written as, instead of this one I am taking n minus 2. It is satisfied. How it is satisfied? You add 3 on both sides. So if you add 3 on both sides, n minus 2 plus 3 equal to 3 plus 3a plus 5b. Now the answer S of n plus 1 is available, so that only I am taking this one. So this will be written as common 3 will be get outside. So it will be written as a plus 1 plus 5b. So for n plus 1th statement also, multiples of 3 and multiples of 5 will be summed. So hence it is proved by general form of integer induction method. The next concept, structural induction, will be discussed in next class. Thank you.